Yeah, hello everybody. I just want to discuss a reaction which I did recently in my workplace, that is esterification. To do esterification, you need an alcohol and an acid. And I have did many reactions during my BSc and MSc, and this is one of the easiest reaction. There's one more easiest reaction that is the pinocolone rearrangement. It is very easy reaction. You just have to take a round bottom flask and put it in the heating metal like a 60-70 degree, and then you add like 15 ml of an acid in it, and then you just slowly add the diol to it. Like the solution slowly changes its color. When I was doing this reaction, my friend was nearby, and then he was adding the reagent a bit faster, and he didn't get a proper yield. I just added very slowly. I actually told him like add it slowly man, because it is given in the procedure like that. I usually don't follow procedure, but for this somehow I got an intuition like I should follow it, because I know the reaction. It has some it has some weird mechanism like a non-classical carbocation, if you remember, like a pinocolone, but it just started very fast. On that day, fortunately, I did follow the procedure, and then I added a little bit slowly, and I got a good yield. Like you just slowly add after you finish your reagent. You just let it heat for some more time, and then you just take the flask and go and dump in the ice water, and you get the precipitate, and then you just filter the precipitate and take it, and then take some of the precipitate, and then you you just dissolve in ethanol, and then you crystallize it. That's a very easy reaction. You just have two reagents, just diol and an acid, and then you can do the reaction. The reaction I recently did is a similar easy reaction, esterification. I have an acid, which is a fatty acid. You can even use an oil, but I used a long chain fatty acid called linolenic acid. It looks like an oil because oil is contains long chain fatty acids, and or maybe oil is just fatty acids. You just have a linolenic acid, but the problem with the acid is if you just take an acid and then alcohol, you just mix it, nothing happens, because what we are doing is nucleophilic substitution. Like this methanol will substitute the OH and it will go and form there, but the methanol is not a very strong nucleophile. It is not methoxide is a strong nucleophile. An acid itself is not a very reactive. Acids derivatives like a carbonyl chloride or acetic anhydride is more reactive than the acid itself. Therefore, what I need is I have to make both reagents a bit more reactive. Therefore, what I did is I added a Lewis acid like boron trifluoride to this acid. Boron trifluoride is very toxic. If you open the bottle, white fumes will come. It's nothing but the boron gas. But boron vaporizes and it mixes with the water vapor in the atmosphere, and it's form a colloid. That white fumes, it's a colloid of a gas and gas colloid. It's very dangerous, and I not even used my mask when I'm performing this reaction. I don't know how much I inhaled it. I'm just playing with my life here. Did you understand? I just took an acid. If you add Lewis acid like BF3, it takes up the lone pair of electron from the CO, keto oxygen, like a acid O oxygen lone pair it will take. Therefore, the carbon will be little bit more positively charged in this reaction. In this, if you added a Lewis acid, it improves the chemical to be more reactive. It makes it more reactive. And then I have methanol. Methanol acid is not a very good nucleophile. You have to make it methoxide. For that you will add sodium hydroxide to it. But I remember some reaction in MSc we made it using sodium, like methanolic sodium. We just in the formation of biodiesel, we just you just dissolve sodium in methanol. I don't know how many of you remember it, but I still remember it. MSC, we make methanolic sodium by dissolving sodium in methanol, but what I did is I dissolved sodium hydroxide in methanol. Therefore, I made both reagents very reactive, like acid into some more reactive and methanol into methoxide. Now we mix both and keep it in the in a water bath for 60 degrees Celsius, and the reaction will happen. The OH will be substituted by OCH3. Then you have to extract the ester from this reaction mixture. What I did is I transferred it into a separating funnel. Ester is a non-polar. It's not as polar as an acid. Therefore, if you add an isooctane, like a non-polar solvent, it will get extracted in it. And then you just shake, and then in separating funnel you just shake, and then you will get the extract in the top layer of isooctane, and then you just that's all. The isooctane layer will have an ester. It's a very, very simple reaction. You just need an acid, put some Lewis acid into it, and then you need a methoxide, methanol and sodium hydroxide. You just mix it and eat it. That's as simple as that. Same like a pinocol, quinaclone. You just heat an acid and then put diol to it. That's all. And there are many easy reactions, like one reaction I remember from my college is we brominate the anilide, acetanilide, like a parabromoacetanilide. We just form it. You just use bromine water. You just get the fumes of bromine. It's not very good. Also, we used the benzoyl chloride, like benzoylation. It is also not very good reaction. It's in my BSc actually, and you get nice flaky precipitate with that benzoylation. I don't know, like I have naphthol and benzoylated it. I guess so. I did a lot of reactions in my BSc and MSc, but this is my recent reaction. Therefore, I just thought I can share it with you. I don't remember I did any esterification with in my BSc or MSc. I don't know. I just don't remember. But this is what I did, and after I did the esterification, I have access to the mass spectro. GC, gas chromatography mass spectrometer. Therefore, I just checked it. Actually, I did it because they want to esterify and analyze the compound. That's why I did. And I analyzed as an ester formation, but there are some side products I just seen in that. Like the OH is substituted in the alpha carbon of the carbonyl in that ester, and that's why this is the recent reaction I did. I find it very interesting. If I just share it with you, that's all.